Woohoo! We are live. This is Math 40, elementary algebra, and we are solving some problems, some equations. These are very complicated equations. So this is the time to get your support animals, your stuffed animals, your highlighters, stickers, your beautiful music, your make sure you hydrate. This is this is serious stuff. These problems can take a long time. But the great thing is if you have the tools, you know what the rules are, you know how to balance things, you're going to be just fine. We just got to take it slowly. If you come across a problem like this has got a bunch of fractions in it, I recommend you write really big, really, really big. I'm not kidding. Now, we dealt with a problem that had fractions in it before. And in that case, the denominators matched. These denominators do not match. So if you've got two fractions and you would like to clear fractions, you want to get rid of the fractions, you've got to come up with an LCD or an LCM. LCD is a least common denominator, and LCM is a least common multiple. And they can both be used. Each of those can be used in this case. Basically, we want a number that will clear both the 2 and the 3. So we need a number that both 2 and 3 go into. So if we've got 2 and 3, we need a larger number that they both go into. Can you think of one of those? Woohoo, you got it. It's 6. So I'm going to use the number 6. Now, you don't have to use 6. You could use any number they both go into. So they both go into 30. They both go into 12. 2 and 3 both go into 42. They both go into 3,000. So you've got lots of choices. The reason you might want to pick 6 is it's nice and small. If you use a really large number, you're going to make a mess everywhere. So what am I going to do with the 6? Well, I'm going to multiply the 6 on both sides. Just like that, like I have done in the past. Once on the left, once on the right, because there's one term on each side. So because I am dealing with fractions, though, I'm going to rewrite the 6 in fraction form. And once I've done that, then it's really clear that what I can do is I can cancel. I can reduce. I've got the 6 here and the 2 here. The 2 cancels and I get a 3. And over here, the 3 cancels with the 6 and I get a 2. Now let's look at what we've got left. I've got 3 over 1, which is 3, 5 over 1, which is 5, and an n. And on the other side, 2 over 1, which is 2, and 11 over 1, which is 11. So 3 times 5n is 15n. 2 times 11 is 22. And there we go. I've gone from a fairly intimidating equation with fractions to a not so intimidating equation. So I got 15 times n equals 22. How do I solve this? Well, what I'm going to do is I want to isolate the n. So I want to get rid of the 15. This is 15 times n. So to undo that, I have to divide. You got it. 15n over 15 equals 22 over 15. The 15s on the left cancel. And I get n equals 22 over 15. And I'm done. Yay! And I know everyone's like, but wait a minute, don't we have to check? And the answer is, yeah, we do. We do. We can do this. We can totally do this. Oh, you know what I didn't do? 22 over 15. Is there anything that reduces? You can kind of guess. I already put a box around it, so I kind of gave away the answer. 22 has 2 and 11 in it. 15 has 3 and 5 in it. There's nothing in common, so it doesn't reduce. Okay, so let's try checking, shall we? So I take my original 5 halves n equals 11 thirds. And I'm going to plug in 5 halves times 22 over 15. Does that equal 11 thirds? Let's see. 5 halves times 22 over 15. The 2 cancels with 22 and I get 11. The 5 cancels with the 15 and I get a what, a 3? Do you see what I got there? 11 over 3. 11 over 3. Woohoo. Woohoo. We did it. 5 minutes beginning to end. Not too bad. Not too bad. Okay, I feel really comfortable and confident. Normally, I'd stop here and ask if there are any questions, but obviously I can't hear your questions even if you have them. But if you do, make sure to ask me. Ask me in office hours, ask me on Pronto, ask me in all the various ways you can get a hold of me. Or, ready? We could totally do this though. Take a deep breath. Hug your support stuffed animal. Okay, I know. Everyone's looking at that going, oh man. I know. Let me write it big. As if writing it big makes it better. It doesn't make it better or easier if it's large, but it makes it less likely that you will make a little mistake. That's why I write big. When you tend to write small, things can get lost in the details. Okay, so as I look through here, I see fractions. I want to clear the fractions. Let's clear the fractions. So I need an LCD or an LCM. I need a number which 6 goes into, 3 goes into, and 9 goes into. So let's see. 9. 3 goes into 9, but 6 doesn't go into 9. How about 12? 6 goes into 12, 3 goes into 12, but 9 does not go into 12. How about 15? No. Any ideas? Keep thinking. Yeah. 18? Yep. The LCD is 18. Now, could you use a different one? Yes. Could you multiply them all together? Yes, but that would be a very large number. That would be like 162 or something, and that's a big number. I would prefer to use a smaller one, so I'm going to look for the least common multiple or the least common denominator, but you could just go for a common denominator, and it could be there are a lot of options. I'm going to use 18 though. 6 goes into 18, 3 goes into 18, 9 goes into 18. So I'm going to look and I see I have 1, 2, 3, 4. There are 4 terms. I'm going to multiply 18 4 times. This time I'm going to be smart. Every time I write the 18 in, I'm either going to write it in fractional form to go with the fraction or in whole number form to go with the whole number. I'm also putting this one in parentheses because of the minus, because it can be confusing. I've got the 18, the 18, the 18, and the 18. Everybody gets an 18. This is exciting. We're getting through it. Okay. In order to keep this so that in the notes it's not hard to read, I'm going to rewrite this. You wouldn't necessarily need to do this in your own work. But again, I want this to be legible in the notes. So I'm going to write this because we're about to go to the next stage, which is, oops, look at me not being able to talk and think at the same time. There we go. So the next stage is going to be canceling. Now, if you did this correctly, all the denominators should cancel. So let's double check. 6 and 18, did they cancel? Yes. 6 goes into 18 3 times. Nothing to cancel here. How about here? 3 goes into 18 6 times. And 9 goes into 18 2 times. So let's see, I've got 3 over 1. That's 3 times 5n plus 18 times 3n equals 6 times the opposite of 1n and minus 2 times 11. Okay, this is 15n, not too bad. Okay, 18 times 3 is like 20 times 3, which is 60, minus 2 times 3, which is 6. That should be 54. I could have also used a calculator. Okay, equals, this is negative 6n minus 22. Okay, I'm going to combine these two. I'm going to get 69n equals negative 6n minus 22. Now, for my n's, I've got 69 n's there and negative 6 n's there. I think I'm going to move these ones over here. I think they'll be much happier. So I'm going to add 6n to both sides. And again, as you get better at this, keep making sure if you put your pen or pencil on the equal sign, there should be one of these on each side. Okay, I think I got 75n equals negative 22. Okay, this is not great. I can already tell that this answer is going to be a little wonky. But I don't care because I'm almost done. I'm very excited. 75n equals negative 22. That's what we got down here at the bottom. 75n equals negative 22. Okay, so what's the last step? Well, this is 75 times n. So what do I do to get rid of the 75? I divide on both sides. And again, this is not a beautiful, works out, everything's great and, wonderful. This is a fraction though. It's still a number. Negative 22 over 75, it's kind of close to negative 1/3, between like negative 1/3 and negative 1/4. It's not my favorite number in the universe, but maybe it's yours. Maybe you're looking at this going, wow, that is a great looking number. Okay, so let's have a little party. Yay, party time, party. I only have 2 hands, so you got to imagine the others dancing. They don't just take turns, but maybe they do. I'm imagining music in my head. Okay, party's over because what do we have to do? Well, here's the thing. Let's talk, just you and me. Just you and me. In the grand scheme of math, if you're doing a math problem, there are a certain number of points allocated to checking. If you do not check, you will lose those points. If on a 10-point problem, checking is only worth 1 point, it may be that you look at the problem and you look at the answer and you say to yourself, that is not worth it. I am not going to check that. And you just lose the points. And it could be that what you do is you say, okay, let me be thoughtful about this. I will set up the check. I will start working on the check, but maybe you don't finish it. Maybe you work on other things, especially on a test when the check is this complicated. Honestly, and I know what I'm saying, and I know it's probably bizarre to hear a math teacher say this, but you got to be thoughtful about your energy, about your time, and about, what math you can reasonably do in a certain amount of time. Now, if this is homework, this is great practice. So I'm going to go ahead and do it, definitely. But I wouldn't necessarily say you should always do it. The other thought is, if your fraction skills are not great, this is a good practice. But is there a chance that you will make a mistake in the check? Absolutely. So, shall we get started? And we'll just be very gentle with ourselves. Don't be too hard on yourself. Just take deep breaths. Keep your friends close. Especially if some of them sparkle. That's always useful. Okay, 5, 6 times negative 22 75ths plus 3 times negative 22 75ths. Does that equal negative 1/3 times negative 22 75ths minus 11 ninths? Wow. Okay, I've got one step. This 3, I'm going to just sneak in a little over 1 so that these guys can talk. Again, what I did before, I'm going to go ahead and do this so that we can simplify. And right now, I'm just going to work on the left side, and then I'll come back and work on the right because I think it's a little overwhelming dealing with everything. So 5 and 75, They definitely have something in common. 5 goes into 5 once. 5 goes into 75. Do you know how many times it goes in? 15 times. And you could double check it on a calculator. Notice I can also cancel here. I can take 2 out of here, leave negative 11, and leave 3 here. So this becomes 1/3 times negative 11 over 15. And then plus, and it turns out 75 and 3 do reduce. This becomes 25, so this becomes negative 22 over, oh, I did it in red. Oh, that's funny. 25. Negative 22 all over 25. Sorry about that. Okay, so that's the left side. The right side, I've got negative 1/3 times negative 22 over 75 minus 11/9. Notice the 3 does not cancel. So this one's kind of gruesome. I'm going to have to do the multiplication. This is a negative times a negative. So I get a positive right there. My Bat Brothers, 2 negatives make a plus. So I'm going to get a positive 22 on top and 3 times 75 on the bottom minus 11/9. And if you're looking at this going, oh my goodness, there is no way anyone could get me to do this, I understand that. Those of you going on to calculus, you really need to be able to do this. Those of you who are not necessarily going on, this may be a lot of busy work that maybe is not as useful. But again, you're watching a video, so you can be having your snacks and enjoying your jammies and all that. When I switch pages, I try not to do anything massive, so I don't actually solve any problems. I mean, honestly, I don't know if I solve any problems anyway. But I don't try to make any changes when I switch over. Okay. Over here on the left, I multiply. 1 times negative 11 is negative 11. 3 times 15 is 45. This is plus a minus, so this becomes minus 22 over 25. Over here on the right, I've got 22 over 3 times 75. I happen to know that this is 225 minus 11 over 9. Now, I know it's going to sound weird that I would choose the right side, but I'm going to choose the right side. My rule is always going to be, if you see something you can do, go for that. Keep working on the side that doesn't feel as frustrating. These two not matching really frustrates me in a way that I don't know how to express. And then I know you're going to say, wait, those two don't match either. And I'm going to say yes. But 225 is divisible by 9 and then goes into 225. So I happen to know, let's go ahead and 225 divided by 9. It's, oh, sorry, you can't see that. 225 divided by 9 is 25, which is kind of cool. So here, my least common denominator is 225. Now, can I just multiply by 225? Oh man, if I could, that'd be amazing, but I can't. You are not allowed to just multiply through. You have to keep the right side on the right and the left side on the left. And you can't talk. The two sides can't talk to each other. So what I'm going to do is I'm going to convert the 11/9 into 225ths. I'm going to say this is 9 times 25. So I have to multiply by 25 on top. And I get, what is that, 275? So altogether, I've got 22 all over 225 minus 275 all over 225. So that's 22 minus 275 all over 225. 22 minus 275 equals negative 253 all over 225. That's a number, isn't it? Okay, that's the number we're going to try to match over here. Do you see why I said the thing about maybe sometimes you just do a little bit of a check, and if it turns out that it's going to take all your time, if I were taking a test, I would stop. I would say, okay, I can come back to this. I would check everything else first, then come back to this if I had time. Is there a really good chance that somewhere in here I've already made a mistake? Absolutely. I am really hoping right now that I get to this number over here. If we do, we're going to have dancing. It's going to be awesome. So back over here, I need a least common denominator for these two. And I know that 45 is 9 times 5. And I know that 25 is 5 times 5. So what I'm going to do is I'm going to mix this all up, and I'm going to say, you know what? What if I did my LCD is a 9 and a 5 and a 5, which is going to be 225, which is the denominator over here. So 11 over 45, convert that to 2/25. So 45 into 225. 225 divided by 45 equals 9, 5. 5 times 5 here times 5 there. So I get 55. I'm converting that fraction. Now I'm going to convert this fraction. 22 over 25, 225. I'm going to multiply by 9 on the bottom and on the top because 225 divided by 25 is 9. So I multiply, and then I say 9 times 22 equals, and this is going to be 198, oops, in black. So 55 2/25 is there, 198 2/25 is there. So I've got negative 55 2/25 minus 198 over 225. That's negative 55 minus 198 all over 225. Negative, remember to use this key, negative 55 minus 198 equals. Are you guys ready for dancing? I'm ready for dancing. I am so ready. Oh my goodness. Big, fat check. Life is good. Massive woohoo. It worked. Now, am I expecting everyone could do this? No, this is a lot of work. This is a lot of fraction work. If you can do this, awesome. If you don't think you could do this, let's keep working, okay? All semester, let's keep practicing. Ask me questions, practice. If you want practice with fractions, ask me for practice. Ask the tutors for practice. We can give you all the practice you'd like. We can help you until the point where you could do this as confidently as I just did, which wasn't very confidently. I was a little worried there. So, dance time. Now's the time on Math Hell when we dance. Dancey, 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 dancey. Okay, that's enough dancing. I'm very excited. We're going to go on to 2.3 next, which I know at this point you would say anything is better than fractions. And I would say, hey, how about word problems? At which point, I don't know. Maybe a little bit better. Anyway, I'll see you guys in the next video. Thank you guys for making it through this one. I know it was not easy. And wow, this is one of the least not boring things there is. So thank you guys so much. You're awesome. Math on.